Okay, Jai Hind all. Myself, Sachin Kumar, working as a professor at Ajay Engineering College, Ghaziabad. Today, we are going to discuss a very important topic, and this topic is called the classic problems of the synchronization. This topic is related to the operating system. So when we talk about the multiple processes and multiple processes want to access the same resources, then we need to synchronize this process, otherwise result may be incorrect. So basically we need the synchronization of the processes if multiple processes wants to access the resources, shared resources at the same time. So synchronization is mandatory to get the correct and required output. So in this particular lecture series, at this moment we are going to explore the various classical problems of synchronization, how these problems may be synchronized. So we have here various solutions to synchronize the problems. Most popular solution is based on the semaphore. So semaphore is basically here a binary variable, and this binary variable is defined by the S, and we have here two functions. Functions are called the wait function and signal function. Whenever any process wants to access the shared resources, then first of all it enters into the wait function, and a wait function executes completely. After execution the wait function, process can get the required resources, and a process is not executing the wait function completely. Process is running the loop and again. The process is looping in the while loop again and again. The process cannot exit from the wait function if process is stuck in the while loop. The process is waiting to get the shared resources. So this is the concept. And second function we need to use here, this is called the signal function, and the working of the signal function is here. After executing the resources, shared resources, we need to invoke the signal function, and signal function increases the value of the semaphore by 1. So in the wait function we are decreasing the value of the semaphore, and in the signal function we are increasing the value of the semaphore, and in the wait function loop may run again and again. So it depends upon the condition. So if we have the value of S less than equals to 0 again and again, then we are stuck in the loop. I mean, we cannot get the required resources. Very simple concept to get the resources, to execute the resources. Wait function should be run completely. After it, we can get the entry into the required resources, and after executing the resources, signal function is invoked, and through the signal function we are trying to increase the value of S by 1 so that another process can get the resources. So we have here variable S. Based on the value of S, we can get the required resources, or process can get the required resources or not. It totally depends upon the value of S. This particular solution is based on the semaphore. Now we have the two classical problems that we are going to discuss here. First classical problem is based on the bounded buffer concept. I mean, we have the buffer and this buffer has the limit. Limit of the buffer is n, and we are going to discuss here one classical problem. Problem is the producer consumer problem using the bounded buffer. The producer is basically producing the item and consumer is basically consuming the items, and our condition is that when producer is producing the item, at the same time consumer cannot consume the item. And similarly here, if consumer is consuming the item, at the same time producer cannot produce the item. So it means that we need the synchronization of producer and consumer problems. So this is the classical problem, and we have here buffer size is n. So to implement this particular concept, this particular problem, we need here 3 semaphore. First semaphore is the mutex. Second semaphore is empty, since initially all the locations are empty. So empty value is here n, and since no item has been produced, therefore the value of the full equals to 0, and mutex equals to 1, whether you can get the entry into the production code or into the consumer code, in the consumption code, then we have the semaphore mutex. Based on the value of the mutex, we can enter or we cannot take the entry into the required code. Now, this is the structure of the producer problem. So here we have the producer. Producer is producing the item. So we need to check whether we have the required space available or not. So initially we have assigned the value of empty equals to n. So when you have initially n space and you are trying to execute the wait function, the value of n equals to the value of the empty equals to n initially. So at this moment, wait empty, process will not struct into the wait function as per the value of the empty, because the value of the empty equals to n. So wait function check the conditions. It is less than equals to 0. No, this is not less than equals to 0 because value is n. And if value is n, then value of n is decreased by 1 by using the code of the wait function. Now the value of the empty semaphore will be n minus 1 initially after executing this particular function. Now we need to check, we can take the entry into the producing item code, because if consumer is consuming the item, then we cannot take the entry into the producing code. So we need to apply here wait semaphore, we need to apply here mutex semaphore, and initially, for example, consumer is not consuming the item, the value of the mutex is 1, and after executing this code, mutex is 1. So mutex less than equals to 0, condition is false. Now the value of this semaphore, mutex semaphore will be 0. Now producing item will work. Now producer can produce the item. At the same time, suppose consumer process wants to take the entry into the code, but you will get the value of the mutex equals to 0. Therefore, consumer process cannot take the entry into that particular shared code, shared resources, as producer process is working. So after producing the item, we need to increase the value of the semaphore that we have used. So after producing the item, we need to write the code signal mutex the signal mutex is trying to increase the value of semaphore mutex y1. So initially value of the semaphore mutex is 0. After executing that code, signal mutex, the value of the mutex will be 1, and signal equals to full because initially the value of the full is 0. We have set full equals to 0. We have produced the item. Therefore, after producing the item, the value of the full semaphore should be 1. So in this way, we can implement the producer process. The producer process may run up to required condition, whatever we want. Now, at the same time, we have the consumer process, because here we have the two processes, producer and consumer. So this is the code for the consumer process, and we have the similar kind of code here. So initially, if consumer process wants to consume the item, then we have the here semaphore. Semaphore is the bait, and this bait semaphore is first of all executing the full semaphore, and since we have produced one item and the value of the full is 1 after producing one item, so bait equals to full. Bait, we are passing the semaphore full. So you have the value of full equals to 1. Condition is true because the value of full equals to 1 less than equals to 0 is not satisfied. The while loop, we are exiting from the while loop and we are decreasing the value of the full by 1. We are decreasing the value of full by 1 through the bait semaphore, and now value of the full will be 0. At the same time, we want to take the entry into the consuming code. How we can consume the item? So if producer problem is running, the value of the mutex will be 0. So we need to bait it. If no producer process is running, you will get the value of the mutex equals to 1. As we have seen in the previous code, after executing the producer problem, we have the signal in the last, and signal is doing the increment. Signal is doing the increasing the value of the that particular mutex, and if we get the entry into the code, then consumer can consume the item, and after consuming the item, we are doing here signal mutex. After consuming the item, we need to increase the value of the mutex semaphore by 1 so that producer process can execute the code. And after executing the this particular after executing the value, after increasing the value of mutex by 1, we are using signal empty. We are increasing the value of the empty by 1 because one of the item has been consumed. We need to increase the value of the empty by 1, and this code will be run again and again till we get the required conditions. So in this way, we can implement the consumer problem. So if we have the two problems, producer and consumer problem, you have seen that only one process can execute the code, and only one process, either producer can produce the item or consumer can consume the item. This is possible through the bait and signal semaphore. So in this way, we can execute our consumer problem or producer problem. Now we have here next problem. This classical problem is based on the reader and writer problem. So we have here two processes in this problem. First one is the reader, second one is the writer. So writer process means if writer is writing anything or writer process is executing, at the same time no other process can execute. Even reader process cannot execute. This is very simple. If you are trying to write anything, at this moment no other process, no other writer process or no other reader process can execute. And when we talk about the reader process, if one reader is reading, then second, third, fourth and number of reader may be allowed to read the code, to read the particular thing, to read the particular resources, but at the same time no writer is allowed. So multiple readers are allowed at the same time, but at this moment no writer is allowed. The writer is only the exclusive. If writer is working, no reader is allowed. If one reader is working, second, third and any number of reader allowed. No writer is allowed at this moment. This is the reader and writer problem. So when we talk about the semaphore based solution of the reader and writer problem, then here we have the two semaphore. First one semaphore is the read write mutex and second one is the mutex. So read write mutex is basically used for the writing the code, and mutex is basically designed for the reading purpose only. But at the same time, if you are trying to read the code, so you should also monitor whether writer process is there or not. For the reading process, we also need the read write mutex semaphore also. But for the writing only, we need the read write mutex semaphore. So if we talk about the structure of the writing process, this is a structure is very easy to understand, and this is the our code for the writer process. So we have here at the first line, we have here bait function, and in the bait function we are passing the read write mutex. So initially the value of the no other process is working, then value of the read write mutex is 1. Then after executing the bait function, since condition will be false as value is 1, so we can get the entry into the resources, writing process will work, writing things will be started, and the value of the mutex has been set to 0 by the bait function. So if one writer is working, so no other writer is allowed here, because the value of the read write mutex has been set to 0 by the bait function, and after writing the process we need to apply the signal function, and signal function is executing, signal function is increasing the value of the read write semaphore by 1. So after increasing the value of the read write semaphore, then other writer function or other reader process may be allowed. So this thing has been mentioned in the loop so that writer process can work again and again up to the required conditions. Now, when we talk about the reader process code, since we have here two processes and these two processes should be properly synchronized. So when we have the reader process, then we need to apply here bait function, bait mutex. Since the value of the mutex is initially 1, so bait mutex, the value of the mutex will be 0. I mean, we can get the entry, and we are using here read count variable. So read count variable is basically increasing the value y1 if any reader process wants to read. Basically, we want to check how many readers are reading the particular resources at the same time. So, if this process gets the entry, after executing the wait function, the value of the read count will be 1. Initially, value of the read count is 0. We need to check read count equals to 1, because at the first time when first reader is allowed in the process, so after executing the wait function and increasing the value of read count by 1, then the read count will be equals to 1. If one more reader is also reading, then read count value will be 2. So, this is the condition read count equals to 1. It will be checking whether you are the first reader or you are the second, third or fourth reader. So, for the first reader, you need to check whether other writer is writing or not. So, if you are the first reader means read write count equals to 1, and if other writer is writing, then value of the read write mutex will be 1, read write mutex will be 0. So, if this is 0, then read write process, reader process will stuck into the wait function. If no other writer process is working, then read write mutex will be executed and the value of the read write mutex will be 0. So, when you have the first reader, if no other writer is there, then you should also need to change the value of the read write mutex. It should be 0. We need to set it to 0 so that no other writer should be allowed. So, we are setting the value equals to 0 here of read write mutex, and we have here signal mutex. Next line. So, signal mutex means this is the semaphore especially designed for the reader process. So, signal mutex is trying to increase the value of the mutex y1. So, by the wait function, mutex has been set to 0. Now, by the signal function, the value of the mutex equals to 1. We are increasing the value of the mutex equals to 1. Reason is very simple. Multiple readers are allowed. Multiple readers are allowed. So, therefore, before reading, we are changing the value of the mutex y1 so that another reader can be allowed if no other writer is there. So, waitx, now after reading, the reading has been completed. So, we need to decrease the value of the read write count, and at the same time we should also increase the value of the read write mutex, because we have decreased the value of the read write mutex, and read write mutex is responsible for the writing process. So, if read count equals to 0, no reader process is there. This is a very important line. If say read count equals to not 0, read count equals to 1, one more reader is there. So, we cannot increase the value of the read write mutex. If no reader is there, then this condition will work, and signal read write mutex, it will increase the value of the read write mutex by 1. So, in this way read write mutex will be 1. So, if read write mutex is 1, no reader is there. Now, we can provide the opportunity to other writer process to write the to work on the writing process, to work on the writing resources, and now we are also increasing the value of the mutex, signal mutex, because we have decreased by mutex by 1. At the same time, we also need to increase the mutex by 1 so that other writers, we can check the conditions for the reader. and last line is the while true. While here walked again and again up to required condition are met. So we have seen here two processes, process 1, producer and consumer problem. The ultimate thing, we are synchronizing the producer and consumer problem. For the shared resources, either producer is working or consumer is working. So similarly, second problem we have seen, second problem is based on the reader and writer. So we have seen that, we have allowed that if reader is working, n number of readers may be allowed. If writer is working, no other process is allowed, even writing also. So this is the code, this is the pseudo code for these two processes, these two problems, and we can synchronize these two problems in very simple manner. Thank you.